Uh, so the standard question, can everybody see my screen?
Yep.
All right. So I'm Tomasz from Getting Data, and I wanted to talk about JDBC relation support in OpenLineage Spark integration. So what is that all about? The newest feature that is in OpenLineage since the last version is that we in the event that we sent the information, not only, information about JDBC sources, not only if they are tables, but also we support queries. So up until now, if you defined the data source as a JDBC table, that was fine. But the moment you tried to do a query, then it's just returned like in the event you only had the complex word as a description of the source. So that was not really that helpful. And later we got the SQL parser, which is the Rust library that we some time ago integrated into OpenLineage. And with that, we are able to parse the information from the query, and with that, give some more information about the data source and about the column lineage. So, right now, okay, I'm gonna go to the next slide. So that's basically how it works if we have some Spark data frame, some operations defined. Here we have basically two iceberg tables that are joined to V1 and V2. They are joined to create a V table, and the V table is a joint with J, which is JDBC source, which is defined as a table here, and that creates the data frame. So in the Spark plan, we can see all the fields that are present in the sources. And it's all fine. We have a table for JDBC because it's all well supported for the iceberg tables. We can clearly see that all the source tables are listed as a relation V2 with all the fields defined. And for the JDBC relation, we have two fields that are present there, which is fine. But the moment we go with query, like the one that is presented here, which is some joins, two other sources, some concat function, like the query plan still only contains the K and J fields, which are really not enough because they do not correspond to the external source, like to any table, nothing. So what we now did is extract the information from the query, parse the query, and from that we get the information like here that we have JDBC source 1 table and JDBC source 2 table, and we have the lineage information about each column that was defined inside the query. So with that, we have our normal column lineage mechanism that relies mostly on those numbers hashtag something, which are the expression IDs. And basically what we do, we first parse the query to get some tokens, and then we map them to assign to them some expression IDs. And with that, we can treat them as normal Spark columns, basically. And that is all collected, and it is sent as a part of a run event. Here we have example, which is generated by one of the integration tests. And here we see that we have the lineage information about the field, the final field k, which is defined here as a number 14. And that comes from the iceberg table. And for the value field, we have 4 fields as a lineage, which corresponds very well to what is actually the situation here. And for our inputs, instead of having only complex keyword, we have defined JDBC source 1 and JDBC source 2, and which columns we have taken from that source. Unfortunately, yeah. Oh, sorry, there is a typo here. We are not all the way there yet, because the only information we are getting is the information extracted from the query. So if somebody gets a select star from expression, then we cannot parse it, because the parser cannot, like, it doesn't have an access to external data source. So it's just not the information it has. And the other drawback is that all the data types has to be inferred from the data types that are present in the data frame that is the result of the query. So that is not exactly accurate, but for now is the best we can do. And we cannot get the complete structures of the data source that we query. So, like, no connection to external sources yet, but that's that. And yeah, I think that is it.
So what you mean is you can get the table name, but you don't get its schema, right? And you know the columns only if they're specifically defined in the query.
Yeah. So yeah, that is the one thing, and the other is because here we have the like one function that because if you do select star on topmost select, that's one thing. But for example, if you do like select star from one of the tables that are joined, for example, then you completely lose any lineage, right? Like there is like no coming back from that. But basically, yeah. So no information besides the things that are clearly defined in the query itself. So if you want to have an information about all the fields, you need to just use exactly all the field names, and then it will be available.
That makes sense.
Yeah. All right. I'm gonna stop sharing now. Where is the button to do it?
Hi, just one question. Sorry, can you hear me?
Yeah.
So what happens in the case of if we're using a view or something? So will we be able to capture I'm guessing we'll be able to capture the underlying tables of the view, right? Since it's coming from the query.
So not like. So here, not only you will not be able to get the information about the underlying table that are creating the view, you will only get information about the columns that you are actually getting from the view. Because like I think what you're asking is that if you have a view and it consists of some tables underneath, will you see the structure of the view or the tables underneath? And that's way ahead. Right now, if you, for example, have a view that has 10 columns and you will do select for 4 of those columns, then you will, like, from the OpenLineage perspective, you will only know about 4 of those 10 columns because they were defined inside the query.